Computer. Okay, we didn't just almost forget to record. We'll have to bust Ken for not having at least called in and told me to record, but now we're starting again. Thank you, guys.
Well, welcome to Connecting Us with Video. Like Brian said, there's going to be plenty of time for Q&A at the end. We're going to do that towards the end. And if you have any questions, that come up, feel free to put them in the chat box. And there are going to be a couple of pre-recorded demos, and I'm going to show those. I'm also kind of going to go over like a lot of use cases here, just to kind of make this all real, and kind of describe what people are doing in the real world with the cloud and video. All right, so I'm going to start to share my desktop, if that's okay, Brian.
Yep, carry on.
And all right, so first thing I want to kind of show you is like, guys, the cloud's getting really cool. I am actually streaming with a service called AWS Elemental Media Live, like right now, to my YouTube live channel. And it's cool, it's like it was so easy to do, and it's like a pre-recorded video of this like Earth and space and moon that I found, and it's just like, this is just a little like taste of like how simple Amazon is making it, so it's really affordable, and it's all serverless. All right, so I'm going to go ahead and start my slides. And Brian, you can see those, right?
It's all good.
Awesome. All right. So there are going to be like 5 hashtags. If you like social media, feel free to tweet. Connect audience, connect customer, connect visitor, connect coworker, and connect robot. So my name is Alex Zumkhawala. I'm an AWS Community Builder. This is the cup I get because I'm a community builder, and just like Brian. And I want to thank Brian for organizing this event. And and I'm just like an independent developer. And this is like a very opinionated talk. I talk about preferences and stacks and software. And it's meant for like beginners who want to learn about Amazon's cloud and video. And don't worry, there's plenty of time for Q&A at the end, but feel free to type any questions in the chat room. So we kind of had this first poll question, and I'm kind of just going to show you the results and kind of go over that. And the question was, have you ever built a web or mobile app with video before? And a lot of our attendees said no. So it kind of gives us a sense of like where we are as a group. And I think this may change over the next 5 years because of how elemental video is becoming in applications. So this is where we are now, but it's gonna be interesting to see where we are 5 years from now. All right, so let's start with the map. There is just so much going on with video today on the internet. And the reason is that there's just a lot of like parts that people can reuse. So here's a map with some of those parts. Right in the middle, we have this emergent technology stack from Amazon. It's a set of serverless applications that we can build with to make video applications. For example, interactive video service, or IVS. Elemental Media Live, the one I just demonstrated, CloudFront, Chime, a meeting application, and Alexa. These are all serverless, and they're aligning, Amazon is aligning these services with an entire stack. And I think the point of this conversation is that this stack is getting really cool. Now, on the left-hand side here, we have some open source software. And let me tell you, users love these open source softwares. If you want to remember one of any of these, it's open broadcast software for people who are just beginning with video. OBS is a very popular open source software to contribute video to in a video application. When an application is feeding video, we call that a contribution, video contribution, a feeder. So OBS is a very popular feeder. Amazon also will discuss Larix Broadcaster because it's very compatible with some of Amazon's services that accept streams of video. You'll hear a lot about FFmpeg, and of course, the web browser. The APIs in the web browser are encapsulated in something called Navigator Media Devices. So, just be aware of that name. So these are like where contribution can come from. Now, on the other side over here, it's like, hey, this is getting really cool. Like the entire stack is lining up, and I can stream video and watch video in the web browser, or I can do it on like custom devices. And this is so awesome because of how all the compatibility is coming together. And of course, don't forget Alexa enabled devices. Alexa, devices are exploding, particularly ones with screens. And I guess another final part of this map I just want to point out is just one framework, video.js. And it's just an example of how people are offering open source software so that builders can quickly pull things together. And this is all about like building quickly, being efficient, right? And that efficiency is coming from the fact that all these pieces are aligning. All right. So why are we talking about serverless? It's because serverless is making video really exciting, and in many ways, video is becoming elemental. And serverless is bringing down that cost. And this is really essential for people who want to experiment and use pay-as-you-go like models for their applications. And so this on-demand like service paradigm that serverless offers, it's the the unique characteristic that is really helping video developers innovate on the cloud. And they can do it with small budgets. Like tiny budgets can do mighty things now. And the reason is that the Amazon cloud services are solving some really deep technical problems that video applications encounter. And I'm going to discuss these deep technical problems that the cloud solves for us. All right, so here's the first key point. Amazon is lining up SDKs, services, and codecs for video on a serverless stack. And this alignment is really saving people time so they can build quickly. Now, video is becoming really necessary to building our future. So this conversation is starting today, but it's going to continue. Today, right now, video allows us to see each other, think like video conferencing, and this is the primary need of video services like today. And there's a lot of like explosion in use of like video applications where people see each other. But in the future, expect in the next 5 years to use more video in other places. For example, machines, they use video as input. And I think this is the future where we're going to see a lot of serverless applications. So, like today, video is helping us connect to each other. And in the future, it's going to continue to do that. But maybe some ways that help us build like smart cities. All right, now, if you're a serverless enthusiast like me, I think this is really exciting because serverless is now getting much bigger than Lambda. For example, Amazon has Kinesis video streams, interactive video service, a suite of elemental services like Media Live, Media Convert, Media Store. This is really exciting because these services we can access them on demand, and they integrate really well together. We're going to be talking a little bit more about AWS Amplify because that's a service that builders can use to build video applications quickly.
Alex, can I interrupt you for just a sec? Somebody's asking if you could define what a codec is.
Oh, great question. A codec is it's kind of like an abbreviation for code decode. And it's like a process to take video or audio and put it into ones and zeros. That it may have some attributes like maybe robustness or error correction or compression, and I'm going to go over later some names of some popular codecs. But to point out, maybe this is a good time to point out, codecs are really important. And if you ever get on a video project, maybe the biggest decision you may have to make is what codecs to use. And I'm going to go over a list a little bit later, what the options are and how they're evolving.
And I'll just say, just as an example of the importance of it, about 2 years ago on the Amazon Fire Stick, they switched codecs, and you could visibly see the images be better. So better compression, extrapolation. I used to be in the video business as well, and so a codec can make the world of difference.
Yeah, great point. There's, like video developers, they have to make trade-offs, like, size versus quality and cost. Because some codecs cost money, other codecs are royalty-free. But yeah, great point. Great point about trade-offs. All right. Any other questions, Brian?
No, I'm just going to keep an eye on the Slack on the chat. So carry on. Sounds
good. All right, so where are we seeing video? And why am I personally excited about video? Like, yes, we're seeing it live events. People are reaching huge, massive audiences online. It's so cool, right? And we see, ways like to be more efficient, like peer-to-peer video, or which is very secure because it doesn't necessarily have to go to the cloud. The cloud just maybe orchestrates it. Smart cities, 5G devices, and things like climate change satellites. This is all kind of like how people are using the internet and doing things with video. And let me take a moment here to really expand everyone's mind of what word video means. It isn't just about cameras now. Like, for example, a climate change satellite could be taking radar images, and many developers will call that like a video image, or like cars will have LiDAR. So just like really broaden that mind. Video isn't just, a gamer screencasting or a webcam stream. It is getting really broad. And that's where I think the excitement is. Okay, so now let's talk about like how essential it is for video to like connect us. And where is this like, opportunity coming from? Well, it's because right now video software stacks are coming together and they solve really tough problems economically. For example, a solution architect, that might be a role on the team. They have to identify hardware devices and software that are compatible to bring a video application together. And that can be really, really difficult and expensive. Well, guess what? There are now like these SDKs that are coming together, and Amazon's bringing them and aligning them. And so now we don't have to spend as much time thinking about that compatibility. This is important because when vendors are creating solutions, for example, people are building platforms for live events to reach large audiences. People are building robots with vision. People are building vehicles that are moving us efficiently around. And, these builders, they want to spend as much time possible, on these problems that are, really, like I want to say, differentiated, right? They don't want to, try to do the same things over and over again that every video application must do. And so that's where I think this is like, I think the change, the paradigm shift. It's becoming very economical. Now, let's also talk about why the cloud's becoming so necessary. I mean, the cloud's becoming absolutely necessary for many video applications. And the first and foremost is efficiency. Like serverless eliminates a lot of the hardware headaches for video on the cloud. And, there are hardware headaches sometimes because, of like auto scaling or finding an SDK that is like optimized for a particular GPU. And Amazon is kind of, making us all more efficient when we use their services because it's eliminating those hardware headaches for us. And again, it comes back to developer tool compatibility. Amazon's SDK, it has this compatibility matrix, and it's really eliminating a lot of the risk involved in creating video projects. We really, these videos, these video applications are really exciting, but they really do have to work together well for it to be an amazing experience for users and for the people who are producing the video. Codec availability. Sometimes, the most difficult decision is what should the codec be for the project. And the cloud is actually spurring like this new era of codecs that are really optimized. And they're optimized for distribution over an internet where, bandwidth may vary. They're optimized to use like cloud hardware like GPUs. So this is just really excitement in codecs, and the cloud is very compatible with these new generation codecs. I think another reason why the cloud is becoming necessary is people. People, they already understand the cloud. They're already connecting to the cloud. There is an emergent way of doing peer-to-peer video, but it's still kind of hard because of the advanced network necessary. So people right now are connecting to the cloud, and this is really important for video application developers when they want to be in the real world and make good decisions that for their platforms that users are going to use. And then finally, durability. The cloud is durable. It has, it has multiple availability zones, regions, and sometimes, video can't get lost because it's too expensive to replace. I mean, imagine you're the guy who, with his cell phone, records some once in a lifetime event. You're on the street and you see something so amazing, and you don't want to lose that video. Putting it on the cloud can give you that, peace of mind. And this is why the cloud's really kind of necessary, compared to putting that video in your own data center or keeping it in your home. So, all right. Now, it's really kind of fun to talk about deep technical problems. I'm not going to go too much into this, but I just want to kind of give people a sense of what video applications encounter. And probably the most interesting one is the network, right? Like how do you transmit video from the edge of a network to like these low bandwidth mobile devices? For example, like if we have a music concert and we want to have like a large audience, in the real world, those devices may not have all high bandwidth. They may have low bandwidth, may have varying speed over time. In the real world, the connections go up and down. And this is a really deep technical problem to deliver video, and services like CloudFront are solving these problems for us. Another real challenge is like high volume video ingest. If you have like millions of cameras, because you have a large IoT, network, things like energy companies, this is really hard problems, but it's getting simpler with this pay-as-you-go model to just create video streams and take them down, and do that in volume. And so for example, Kinesis video streams, it's very easy to just create them and take them down. Another real challenging problem is reformatting video. It kind of, again, it goes back to creating a large audience. Not all devices can read the same codec. So sometimes people produce video in one format and then use Amazon's cloud to reformat it in many different ways, and then give users the choice of what format to use. So these are kind of the real big challenges and the deep technical problems. And again, Amazon is doing this at a very low cost. And finally, I think something that is like almost like one of Amazon's competitive advantages that many users want to leverage is the proximity between storage and machine learning computation. So what does that mean? Like Amazon can host your code, it can run your code. And when it's really close to storage services, serverless services like S3, it can be more efficient. It can get done more quickly, which can lower that cost. And honestly, this is like why many people are not building their own data centers anymore, or not running them on their like laptops. They want to leverage that efficiency of the proximity between storage and computation that Amazon's offering with its serverless services like Lambda. All right. So okay, what else? Let's go into construction. Construction is kind of like, hey, we're going to go over some use cases right now, and we're going to talk about the stacks that they are constructed with. So like we're going to answer the question like, how are solutions that connect us built? All right, so this is like our first kind of like discussion of a use case, like and it's hashtag connect audience. And here's the question: how do I make a website that streams a live event? Well, so you got to start with a source for that video, and that can be whatever you like. It could be a camera, it could be a pre-recorded video, it could be a satellite, whatever it be, but it's got to be a source, and it doesn't have to be on the cloud. Then we got to intake that video for that live event, and for example, we could use AWS Elemental Media Live to intake the video that is fed from a source. Now, to really expand this audience, remember, we want to connect a musician to a really large audience, for example. We want to reformat that video and format it in different ways. So we're like reassembling the video, maybe with like into maybe small segments that can be downloaded one at a time, so they don't have to download the whole thing. Maybe different codecs, different screen sizes, whatever it may be. That formatting is really important, and it must be done quickly because it's a live event, and the cloud can do that for you quickly. Now, Lambda is really important for many live broadcasts, because Lambda can augment video. And Lambda is like, I think, where an exciting part of innovation is happening, where people just take a video stream and then they make it better. For example, they could add captioning in many languages, and I'm going to demo that for you a little bit later. Or they could actually modify the video stream. And now, S3 is important because after we augment it, we want to store that augmented stream. So we put it in S3, which is really reliable. And then finally, we want to redrive that video, right? We want to get it out to a large audience. And that's the last step in, like, I don't know, say a website that is, creating a live event. And we can use CloudFront to do this redrive. It has a large edge network. It's really well built to, give video to these devices that maybe, have spotty internet connection. Because again, in the real world, the internet's not perfect. But CloudFront can help you reach that audience for a live event. So that's kind of like our first kind of like use case. And so now let me give you like one tip, and I have 3 tips. We talk about that live event and that website, right? Well, serverless can host nice metric machines about video quality for people. For example, when we have that live event, we maybe want to know how the users are experiencing it, like, frames per second, quality score of that video, bits per second, they're receiving. And maybe we want to, stream that from the user's devices into like, Kinesis data streams, and then store that on S3, and then we aggregate it with AWS QuickSight. So then we have like a nice little dashboard. We can do this really quickly with serverless, metric machines, and we can build those on the Amazon cloud ourselves. And this is really cool. And, because metrics are really important to successful applications. But you're on your own sometimes to build these metrics, depending on your use case. All right, so we kind of talk about this future of smart cities. Like, what does that really mean? Well, I like to, I hashtag this connect robot, because robots really are going to have to connect to our world. Sometimes they may have to see us, or maybe they have to see things. So here's an example, another use case, like make a robot that finds recycling bins that are full in a smart city. So it's like, how do we efficiently find work areas for these robots? You can use services like Kinesis video streams to get the video from the robot to the cloud. You can use Lambda and EFS to maybe identify, whether the bin is like, something that is full or not. Just a really simple example. But these are kind of like the I would say the future uses that people are really experimenting a lot with. So here's another use case. I tagged it connect customer, And so here's what I asked, like make an autonomous vehicle that counts the number of passengers for an urban planner. How do we do that? Because if you've got an autonomous vehicle that's in public transportation, we want to know how much it's used. Well, this is called video analytics, and you want to remember that expression, video analytics. And it's a very popular use of the Amazon cloud. And the idea is that we take the video and we use it to track an analytic metric. For example, the number of people that are using video, using a vehicle. So very exciting, video analytics. And we can kind of think of these as use cases that connect, maybe the service provider, like the public transportation company, to their customers. They want to understand their customers better. Grocery stores are doing this a lot. Some grocery stores, they count the number of customers that come in because they want to understand their customers better. So like these metrics, they can really help a business understand their customers better. And especially the ones that I think are used by, demonstrated by like Amazon and other grocery stores with like the Amazon Go. A lot of that is like video based, and I think we're going to see how a grocery shop change because of these exciting new ways that video can change a grocery store. Think about that. It may change the way we grocery shop. All right, so developers, right? Like, what's the theme here, right? The theme is here we have like some reusable parts that we can put together because they're Amazon's aligning them. For example, we have open source SDKs like, for example, the Kinesis video stream has a producer SDK to make it easy to get video to Amazon Kinesis video stream. And again, these are serverless kind of parts. And some of them are like, I would say confirmation templates, which kind of add things to the cloud with these serverless services. And of course, we see a lot of JavaScript video libraries like Video.js, all reusable. GStream, if you like open source software, very popular software, and it can stream video to the cloud. And then of course we have Amazon Video Services. And another mention here, AWS Amplify. I think it's a really amazing service to synthesize video applications quickly. And it just pulls together all these things that are, like I'm going to say reusable from other, other kind of components, and it makes it easy to kind of just go ahead and use them quickly. I think codecs are also kind of very usable. I think the containers for video, and I think video service, machine learning services like recognition, we can kind of conceptualize that as a reusable part. If sometimes I think people like to share their APIs, we call this like an API world. Well, people are actually hosting, their reusable parts on EC2, like for example, like SageMaker endpoints. And so, this doesn't just have to be software. It could be like APIs hosted on the cloud. So like, how do people quickly build websites now, right? There's so many ways to build a website. And well, here's an example, and the hashtag is connect audience, like, hey, how easy is it to build a live streaming video application? And Amazon has a service called AWS Amplify that can quickly synthesize an application that you can, use Amazon's video on demand services to kind of offer features with. And so I'm not going to demonstrate AWS Amplify here because there are many videos on YouTube that do this, like this one here. But to kind of like, conceptualize how easy it is to start a project, you just can type AWS Amplify in it, because Amplify is the name of a command line tool as well. Amplify add video, Amplify publish, and then you're on your way. And this is really shortening the time it takes to make an application, which again is going to make it more economical to do so. All right. So I'm going to take a moment here to kind of go over the second poll question, and we're getting close to to the demos. Second question: have you ever used FFmpeg? And it looks about 50-50, a little over 50%, which is cool. I think that means that a lot of people are doing things with video, maybe off the cloud. Okay, so here's another tip for you. Like FFmpeg is a nice universal video tool. FFmpeg is like we can use it to reassemble video, augment video. We can use it to modify video, and it's free. It's open source. So, for example, sometimes people will build Lambda functions, and they'll want to use FFmpeg. And when Lambda functions kind of get big, there is a limit of 512 megabytes. Sometimes people build Lambda containers that can get up to like 10 gigabytes, and they can maybe put FFmpeg in there. Sometimes people also build with Lambda layers. They find ways to make applications small, and then they put the layer on the cloud once, and then many of their Lambda functions will reuse that layer. So there are lots of things that people are doing to put FFmpeg on the cloud so that they can use it in their code. And it's just a really nice tool to kind of be aware of. All right, so now let's talk about patterns. Patterns and like how people can build video solutions. And I want to take a moment here, Brian, because Amazon is really starting to, I think, change how they present to builders ideas. Like, for example, Amazon recently launched a new service called Solution Constructs. And these are like explanations of how to put services together in patterns. So I think this is kind of like exciting. It kind of is a sign that the cloud's getting easier to use. So now we need to think about patterns. Now, here's my key point too, like the second most important thing I'm trying to say here. The exciting patterns are more advanced than simple recording and playback. What I'm trying to say is that, video applications that I think are exciting and novel and like where we want to start thinking, we want to go beyond recording and playback. We want to think about how to like augment video, how to use video to do things that are a little bit more advanced. And so let's go over some patterns of like what is advanced. So here's a pattern. I call it the Netflix pattern, and we can do it with serverless. This is #connect_customer. And the idea is you store video on the cloud, you transform it so it's available in lots of different codecs and formats, and then we deliver it wherever the users are. So it's sort of like connecting people to video that's already recorded. This use case is called video on demand. And you want to remember that expression, video on demand. So the idea is, hey, I've got video that's all ready to go, and I want to just make it available everywhere. So how do we do that with the cloud, right? Well, you may want to store it on S3 because S3 has a very amazing storage capacity, has different tiers to keep those costs, managed. And then we can kind of reformat and transform that video with the service AWS Elemental Media Convert. And then of course we want to deliver that video to all over the place, get it to as large as audience possible. We can do that with AWS CloudFront. So like in a video on demand solution, people ask questions like, hey, how do I create media files that I can play on lots of devices? Netflix has so many users, with different devices, right? And the idea is like, how can we make it quick to like watch a video? People, when they want to watch a video on demand, they want it to start quickly, this kind of a store, transform, deliver pattern, and it can do that now. We kind of want to talk about something about like getting video to people over the internet. And that is that HTTP, one of the protocols we all are familiar with, now can, it supports live streaming, so it's something that Apple created, like HLS, HTTP live streaming, and this is like was like a breakthrough because it means that like we could do video on demand over the internet and with standards. There are other standards too, like Microsoft Smooth Streaming, like Dash ISO, and these these really amazing formats. They did something that was really incredible. Like they take video and they make it possible to adapt the bit rate of that video stream, how much people are downloading per second, you know, so that a user, could maybe watch different qualities, or maybe they could watch with different bandwidth levels, like high bandwidth, medium bandwidth, low bandwidth. So this was really amazing. And this was kind of like a part of the deliver portion of this pattern. And again, it's a deep technical problem that we no longer have to think about. We can just go and use the solutions.
Alex, can I ask a question? Because I used to work in video on demand, and one of the things was getting the for closed captioning was getting the text channel that might be available along with the video. And do any of these tools let me access that?
Oh, great question. One of the demos actually kind of demonstrates an architecture of like captions and video. And the answer is it's possible because the players, they understand how to get a video feed and also get maybe a text feed that goes along with it. And Amazon services like Media Package and Media Convert, they support the addition of text if it's not there. Also, Lambda actually runs on the edge, and they call it Lambda CloudFront. The demo I'm going to show you in a second uses Lambda CloudFront to kind of do that type of addition. Because ultimately, because the challenge there is that the video player has to ask for that text. So basically ask CloudFront for, hey, give me the text.
Okay, because I'll say one of the things we were looking at doing at Motorola was extracting the text and then calling Google Translate live, letting you have closed captioning in whatever language you wanted. But
awesome.
Motorola didn't actually do it. Anyway, carry on.
Yeah, it's very interesting because the demo kind of does demonstrate captioning, and there's even a possibility of translating it. Right. I'll get to that in just 1 second. Anything else, Brian? Okay, I'm going to keep going. So here's another kind of like a overview of like the live music concert pattern, right? We're going to connect people to audiences. So what do? We have a video stream, we have to transform it and deliver. Again, deliver it to as wide an audience as possible. So the things that people are thinking about is like when they have these platforms for live music, it's like, hey, how do I make sure that stream keeps going? How do I scale it up when I have lots of users who just just start watching it? How do I make a custom ad? How do I make it sound great? These are kind of the things that people are thinking about. You can use the cloud to do this because there are codecs that can make things sound better. For example, on Amazon services, they can accept HLS. They can deliver HLS and accept a video and sound that uses like very high quality Dolby. So, if you're on a video project and someone says, hey, I want to make sure the sound is great for the viewers, you can use it. You can kind of configure Amazon services with special ways to do it. Like for example, with advanced Dolby sound. So, again, this pattern of video stream, transform, deliver, it's kind of up to you to determine like the quality of that delivery, based on what you configure. And it's up to you because that quality can maybe affect the cost. And maybe affect the number of devices. But it's possible to make it sound really great. All right, and so I'm going to kind of go on here to like this first demo, Brian, and I'm going to play it on YouTube. And it's called "Video That Is Hard to Understand." And I'm just going to flip over to YouTube. Oops. Whoa. This is the first demo of connecting us with video. It's named Broaden an Audience for a Hard to Understand Coworker. That's hashtag Connect Coworker. Here's how it works. I'm going to stream a camera feed with audio, video, and no subtitle from my Android phone. I'm going to replay that exact stream with a bit of a delay, but with an augmentation from the cloud subtitle. This is a cup with water. The subtitle will show up in a little delay, maybe 10 seconds. Now, let's go over the stack, how this all works. The technical problem described in this map is augmenting a stream with subtitle and doing so quickly. It's not completely serverless, though there are several services that are serverless. For example, MediaLite is a serverless Ingest service that will receive a stream and make it available to other services at the time. Here we use transcribe and translate to create subtitles, and we store those in S3. And that edge reassembles a new stream that can be distributed with CloudFront. My Chromebook watches that stream from CloudFront, augmented with subtitles. Oh, great. And so that demonstration, you could do it yourself at your home. If there's a little QR code here that you can scan, so I'll give you a second to scan that if you want, and it'll take you to a GitHub repository with some third-party CloudFormation templates. So here were the problems that, in this use case that were solved, right? The audience maybe can't understand the speaker, so the captions make it possible to understand them. And natural language processing is, it's very expensive and difficult machine learning. But isn't it kind of cool how we can just use the cloud to do it? And again, there's a pattern here where we bring many services together to do something, like AWS Transcribe and Translate and Lambda at Edge, and there were many others there that we went over. So this is just really neat. And it's so amazing that we can do this at a low cost. So I have about one more demo, and we're almost done. I'm just going to touch on a few more points. So I'm an advocate for Amplify. So I'm going to talk about AWS Amplify a lot. In fact, I describe Amplify as something that can help us build apps. And for example, we can build web apps, we could build Android apps, iOS apps, and it helps us synthesize these apps quickly because it's like an extensible CLI. For example, there is a CLI, and then we can add extensions to it. And one of the extensions to it is Amplify Video Category. And so this is kind of like how you can, not build a video application quickly with Amplify, and you can get a complete app stack. You can, so think about what's in the stack here, like HTML5, JavaScript, an Amplify JS SDK, and they're all aligned for us. They're all compatible with each other, and then on the cloud, we have Elemental Media Services, Lambda, S3. Again, they're all aligned and they all come together for us because Amplify, synthesizes this all with templates and code quickly. And when we do it quickly, again, it saves us time and money. All right. So and then another challenge is that sometimes people have solved video problems with custom stacks, and maybe those custom stacks are expensive to maintain. So one benefit maybe using these stacks that are already aligned for you is you can kind of reduce your cost. And maybe you don't have to maintain that custom stack anymore. So here's another example. Using Kinesis video streams for video analytics. For example, maybe we want to count the number of people, number of customers in a store. We can kind of stream that video to Kinesis video streams with GStreamer and the Kinesis video stream producer SDK. And then when we're on the cloud, we can use necessary serverless stack, the AWS recognition, serverless service to kind of recognize people and generate those metrics. Kinesis data streams to kind of get those metrics out back somewhere. So this is really kind of really coming together nicely for us, right? I think we can call these things that do things with video on the cloud machines, and they're software machines. And I think we're going to see a lot of software machines in smart cities that do this type of video analytics to power our smart cities. So I think this is a very, very, very interesting. And I love talking about this because I think this is really important to our future. But right now people are doing simple things like, maybe a building owner wants to count the number of people that come in their building every day because they want to understand how often they have to clean it. These metrics can really make decisions possible, and that's the idea of a smart city, right? You have data to make better decisions with, and video is an important part of that because we can then use video to create metrics, and we just call that video analytics. Now, another challenge I think I really want to talk about with that I think this SDKs and everything that's lined up for us is that sometimes video you can't just send a large MP4 file to the cloud. Maybe you want to split it up into little segments and then send those segments one at a time. And for example, if we want to get it to recognition as a stream, so that we can then ask recognition to do some video analytics on our video, we can use Kinesis video stream producer SDKs to do that kind of bite-sized sending and forming it in a container like NKV, which is a format that Kinesis video stream supports. You want to remember that acronym, NKV. And again, the stack does this for us. It can split up video into NKV segments and just send it. So we don't have to do it ourselves. And then once we get it, to AWS recognition, we can, say, hey, how many things are in this video? How many people are here? What kind of scene is this? And all these really interesting questions that we can then go do things with. Here's something I kind of had built for a client on AWS IQ. They wanted a really simple website where two people could, get in a video conference together. So we call this application face-to-face. It's like, hey, people want to meet. And it's just two people. These people can work together. So this is #connect coworker. And I built this really quickly with Amplify. Amplify gave me everything. And when I needed to kind of get the video together, I used AWS Chime. Chime is Amazon's meeting software. It was just it was really kind of challenging. The developer challenge to get this done in days, not weeks. And I was able to do that because I used AWS Amplify and Chime. All right. So Brian, I'm now going to give my second demonstration here, and it's titled Alexa, Show Me Who's There. And I'm going to kind of drop over to YouTube and go ahead and play it. Hi, this is the second demo in the Connecting Us with Video talk. It's named Alexa, Show Me Who's at the Door. And it's
It's hashtag connect visitor. Here's how it works. I'm going to ask my Echo Show to show me the video of who's visiting. I'm going to simulate a doorbell with a camera. My Chromebook is right here. The Alexa, Echo Show, and the group are connected to my bright home Wi-Fi router. Let's see who's visiting. Alexa, show me the doorbell. Alexa, stop. It worked. Now let's go over the software stack so you can do this yourself. Here's a map. It's a serverless stack. The typical technical problem is streaming video from the Chromebook with the webcam directly to the Alexa Echo Show in a peer-to-peer manner that stays on the internet. This is called a WebRTC peer-to-peer video stream. It's possible because of the Kinesis video stream service with a resource called a signal channel. Chromebook and the Alexa Echo Show can coordinate because of the signal channel. The virtual camera on my Chromebook feeds video to the Alexa Echo Show screen, which receives video, and all can go on the internet. The Alexa smart home skill controls what happens when I talk to an Echo Show. It's a Alexa skill hosted in a daemon function in Node.js and JavaScript. This is all kept safe for the log with Amazon. I log in with Amazon to my Alexa Echo Show, and I also log in to the Alexa app for a my Android phone. Finally, I link when I log in with Amazon my doorbell smart home skill to my Alexa account. This keeps it all safe.
Okay, and the stack for that, you can do this yourself at home. If you want to scan this QR code, you'll get some CloudFormation templates from a third-party repository, and it brings a lot together. The Alexa Skill Kit, Node.js, log in with Amazon, Kinesis video stream, and it's just amazing how this all can come together so quickly. So we don't have much short time, and I'm going to kind of want to get to the Q&A soon. So I'm just going to touch on a few other points real quickly. So that second example was like an example of peer-to-peer video. I'm going to explain that just a little bit. So like these stacks, a developer has to make a decision, make a custom stack or maybe use one that's pre-built. And I think serverless is a nice way to avoid bit rot. So this is my third tip for you. Bit rot starts when code starts to smell bad, it's not maintained. If you think of like T0 as a time when you write code, the smell gets worse as we get further away from T0. Serverless is kind of like a nice way to kind of just reuse parts, and then we can avoid bit rot. Now, serverless can't necessarily scale to infinity, when we don't always have to use the cloud to distribute video. That example was an example of peer-to-peer video in that demonstration where the virtual doorbell camera was streaming video directly to the Alexa device with the screen, right? And that was possible without sending the video to the cloud. And so that solution, it avoids the expense of that video per second of ingest to the cloud. Remember, it's pay as you go. that solution, it was peer-to-peer, so the video stayed off the cloud, and the cloud was just there to help organize the two devices when they wanted to transmit video to each other. And this is called a WebRTC connection, and it's just a great way to maybe lower that cost, because again, serverless doesn't necessarily scale to infinity. Sometimes we have to think about how to be efficient and keep video off the cloud too, and just maybe use the cloud to orchestrate it. So okay, and CloudFront is a very nice serverless video service at the edge. Okay, I'm going to go a little bit quicker now, just to kind of get to this Q&A. Okay, here's my third and final point. The third, I really want you guys to remember this. You know, Lambda is an exciting computing platform to augment video. You know, it's like Lambda has, you know, it's really well positioned in the serverless architecture because it gets so close to data, and we can very easily reuse code. Like for example, we can use FFmpeg, or we can use other libraries in Lambda functions, and you know, where people are kind of differentiating themselves and differentiating their applications, they're taking that video and they're somehow augmenting it. Okay, so now we're just going to talk about monitoring machines. So just what is a monitoring machine? Well, we can use a machine to like monitor live video. And the cloud makes it possible for us to kind of just bring these streams up and down in short amounts of time. So we can like funnel video from like maybe grocery stores to these monitoring machines. And you know, we can funnel video from robots to these machines on the cloud that maybe monitor the video for us. And so these are hashtag connect customer, connect robot. And you know, what's really neat is that once that video gets on the cloud, it's possible to customize it, and we can choose our compute platform for that. We can do like GPUs, CPUs, or TPUs. It's really up to us where to host the code for that, and we have a choice. So now I'm going to quickly touch on assembly, which is like probably one of the most popular use cases of video today. But again, it may change in the future. But today, a lot of people are producing video and then assembling variations of that video or reassembling the video on the cloud. Very popular use today. You know, we can call this transcoding or reformatting. Super popular with people who produce videos. And we can kind of think Amazon services, they're like robots on the cloud for us, like Elemental Media Package. It's like a robot that assembles copies. And, you know, people, you know, they have a choice. They could maybe do this on their laptop, but their laptops may run out of memory because their laptops have finite capacity. People can then use the cloud to get over those limitations of like a laptop. This is a very popular use of the cloud, just to kind of get over the limitations that people maybe when they do it themselves. Another kind of really exciting, you know, kind of idea is how to, you know, robots maybe, you know, are in our physical world, and you know, we kind of need to connect to the robot in some sense. The robot needs to be able to see us, understand if we're in the path of that robot, you know. And so Amazon has services like AWS RoboMaker that allows us to control robots, and they have extensions to these services that allow these robots that people build with Amazon services to get the video to AWS recognition where it can do machine vision. It's just really, really cool, a very interesting use case. So, and you know, it's very exciting to see where, like, I think robotics and machine vision will go with Amazon services. And the final one I just want to talk about before we get to Q&A is vehicles. So what's going on with this use case? Well, vehicles must drive well on the open road. You know, vehicles have to know when to stop when maybe there's a person in front of it. How does it do that? Well, these autonomous vehicles, they have machine learning models, and they can, you know, in automobile makers, they can make those models on the cloud with lots of data. And if you're ever wondered, where is Amazon Web Services getting all its growth? Like, where's it come from? Like, who's doing all this stuff on the cloud? You know, vehicle manufacturers they are doing so much of cloud and making it explode, frankly. And what they're doing is they're taking video from vehicles and they're storing it in S3. And then they're using that video on S3, which is very close to compute on the cloud, to very efficiently train models. And they don't just do this once, right? Because they repeatedly do this over and over again as they get more data to kind of tune the models. And then when they have that really nice model, maybe they put it back on the vehicle that's not on the cloud. Now, so these solutions aren't perfectly serverless. S3 is serverless and can store that training data and that validation data. But you want to count server full in when you want to consider solutions that train models. But I think here's like the key takeaway, guys. Like S3, it's keeping this data on the cloud. If you want to, when we talk about why is Amazon so competitive, as services compared to like custom data centers, Amazon's uniquely differentiated themselves because it's got that storage really close to that serverless compute or even serverful compute. And they solved that technical problem. So and people can now leverage that to do exciting things like develop machine learning models quickly. And then that means that these vehicles can drive better on the open road. And isn't that exciting? Because these vehicles that are autonomous, they have the possibility of being more efficient. And I don't know about you, I'm really worried about climate change. And then the number one way that I think we can all improve our energy use and be more efficient, that people talk over again, is with transportation. So I think these autonomous electric vehicles are really exciting, and the cloud has it's part of this picture of bringing them to the road. And so this is kind of like the last slide. It's kind of want to talk about codecs. Selecting a codec is a big deal because different codecs have different economic advantages. For example, some codecs are royalty free. I think, try to remember AV1. It's the codec right here. This is a codec that Amazon and other technology providers are, offering here. And they're trying to lower the cost of video projects with this codec because it's royalty free. Now, codecs are really exciting because people sometimes make up their own codecs. Maybe they can get a unique competitive advantage with a codec that compresses data really well and still has really high quality. Because the codecs can affect quality as much as they can affect cost. And so in their new codec coming up all the time because the cloud services, they can optimize the hardware and the software well to be very efficient with a particular codec, and they do it all for us. So we don't have to kind of align all that hardware and software for a codec. I think AV1 is really popular, but H.264, a lot of content is in H.264, HEVC, VP9. And there's so many more. You're just going to see lots of codecs come up. So just be prepared to always kind of think about that decision. I think the ones that are most exciting are the ones that are really compatible with HTML5. Because HTML5 is a really amazing standard. A lot of things came together so that people could watch video in the web browser because of HTML5. But then there's also these other really nice kind of say formats and containers for video, things like WebM, WebRTC, MKV. These kind of containers for encoded video have also made a difference, and we can reuse them. We don't necessarily have to invent our own when we want to make a video application. At the end of the day, we've got video, and we got to convert it to ones and zeros, and that's what these codecs do. But the competition and the advantage, like people try to outsmart each other by coming up with the best use of codecs. So it's kind of a place of innovation and technical creativity. All right, so Brian, that's all. I'm ready for Q&A.
Okay, and just while we are doing Q&A, I figured out how to do the second poll, so I'll have the second poll going while we're going. And I'll also say that we have a survey in the chat, and we also have a giveaway. So stick around. But questions? I actually have a question. Oh, go ahead. You go ahead.
Okay. Yeah. Thanks for doing the presentation. And it sounds like codecs is just synonymous with format. Your format of capture and format of playback, and then the format is optimized for streaming or lossless video and things like that. But is there any better understanding or metaphor for codec, or is it really just start with codec and then find out whether you're doing streaming or not, so you know whether you need to process things in streams or you're going to save it and play back? Because I missed a couple of things. Sorry, like somebody came over kind of at emergencies, like personal business meeting, but I hopefully didn't miss that in the presentation, but a little more elaboration on that would be super helpful, because that helps. The format, the codec, helps me understand the purpose and the use, and then the purpose and the use helps dictate what cloud systems or peer-to-peer protocol you'll use. So I figure if I understand codecs from you, then I'll understand the rest eventually.
Yes, and I think you got that kind of idea, right? You start at your use case and then you work backward, right? So for example, a live music concert, that's the use case is like reaches large audience on as many devices as possible. So using a codec compatible with HTTP live streaming might be the smartest thing to do. So that's when we want to talk about delivering that video. Codecs also come up when we come up producing video. So remember, you take that shot of that video and you only want to take it once, right? Well, you may have to select a codec for that video when you record it. And sometimes people pick the highest quality possible for that recording. And then what they do is once they have that really high quality recording in a nice codec like H.264 with a very high bit rate, because remember, each one of these codecs, they can vary the quality by setting things like the bit rate. Higher bit rates typically means more quality. So they record maybe video at a very high bit rate, very high quality, and then when they want to get it to a large audience possible, maybe it's like a college student with a small device, maybe like corporate employees with larger devices, such variation. They use the cloud to transform that video and reassemble it in many different codecs. I think the second kind of point here is that you're not stuck with a codec. Once once you record something, it may be in a codec, but you're never really stuck in a codec because you can always reassemble. It's just that there's a cost every time you reassemble it. You got to pay for that, and then you got to store those different variations. So, so one way people try to minimize the cost is to try to get to know their users, like what internet service providers they have, what bandwidth levels they have, what devices they have, what operating systems they have. Where are they physically located? How close are they to a edge network? Getting to know the users is an outstanding way to start. Making it more efficient, so you don't have to maybe do every single possible format. You can maybe kind of narrow it down a little bit to get more efficient. So I hope that helps you with the decision-making process of selecting codecs. Does that kind of question answer you're looking for?
It does, because I wanted to understand the theme of your presentation, which sounds like pick the right codec. But now, because we have cloud, we have like peer-to-peer streaming. So you just, look up at a directory, I'm going to send my video straight to this person. And then when you have live streaming, sometimes, like you said, the concert example is good because you want high quality audio, high quality video. But regardless of what codec you pick, the distribution system can switch formats based on people's bandwidth and their device and all that other stuff. So like I have now a question that challenges the previous question, just now that I understand your basis, which is like, for people who are not experts, who would seek out a video expert like yourself to help with any given project, can we take more confidence in the fact that the distribution system nowadays around content takes care of a lot of that mystery for you? We just need a Rosetta Stone for picking the right pieces. You know what I mean? Because like some videos are like download and play. Some of them are stream. Some of them are whatever, like something new I probably don't even know about. And I had more faith in knowing that I could just find the right solution, which is easy, like quick time to value, rather than all the small details like you're saying, like the frame rate and all the other stuff. So that's the second question. Like, is there an easy Rosetta Stone I can use as a non-expert, or do I need to really start learning more of the details so I can communicate it to the expert?
That's a good question. Like, is there like a universal way to distribute video that's compatible? Or is there a way that can translate really well? It's not a question that's come up. I actually don't know how to answer it perfectly. The question I counter as an expert is like, oh gosh, there's a cost. There's a cost to like transforming and reformatting it. So what do we do? What do we reformat it to? And then usually that means getting to know like the audience's devices, because there isn't a way to kind of like because there is a way to maybe reformat on the fly when for that wide audience, but there's a cost. So and because there's a cost, a lot of times when people will say, let's maybe like pick a certain number of codecs, transform it, and then we'll stick with that for maybe like a year, and they don't want to then spend that money again to reformat it, because maybe the audience, the number of people who have that new codec is too small, so they can't justify the cost to reformat it, and they're and maybe they don't have control over those devices that users are viewing on, so maybe too difficult for them to maybe reformat it on the fly from one format they already have the video in. So that's I hope that gives you insight to how I'm like exposed to this challenge of like picking codecs, and it really comes down to that there's just a cost every time to reformat, and people are trying to optimize those costs.
Yeah, it sounds like, cost is a bigger driver. I was hoping you were going to say HTML5 because there's a line in the sand at some point where older devices and strategies aren't working well enough for the future, and everybody just says, hey, use this. And then if you want something higher quality or like more stable for streaming, then use this special one, which is better optimized for that. So I'll just keep learning, and then I got to figure out the lingo and the technologies. But thank you. Thanks for at least explaining this much.
Yeah, and just get, and for people who love what's going on with the cloud, let me give you a little bit more insight. Like the codec is really important when we talk about distribution, that from CloudFront to those devices, because we need to compress it and get it over the low bandwidth. But let me tell you what's going on the cloud. Maybe from after the video is produced and given to the cloud, people aren't necessarily thinking about compression. They're thinking about, how can I use uncompressed video at 60 frames per second and do whatever I want with it? You know what I mean? So so Amazon's like, what they're doing on the cloud is kind of adopting and offering customers really high bandwidth EC2 instances, really high bandwidth network adapters, API interfaces like CDI. Amazon now offers CDI, which is in contrast to something called SDI, which is really popular. And CDI is like an invention that Amazon is offering its customers, where people can now move around video on a network that like the internet, which isn't reserved, meaning that you don't really know how much bandwidth you're going to get on the internet. You just kind of hope for it, right? We call that an unreserved network. And they're trying to figure out how to push like uncompressed live, uncompressed video at the highest quality highest quality around these EC2 instances that can then do compute with them. And what they think is like, what's the latency there? It's like, how can I like get video from one EC2 instance to another in like less than a millisecond? So it's like maybe just one frame out of every 30 in a second that, of a lag, because there is a lag every time you pass it around. So I'd say on the cloud, Adrian, I say I think of the excitement that people are thinking about is how to do everything they want to do with uncompressed video. But then again, your question was about delivery and distribution in HTML5, right? Once it gets there, it's going to get compressed. But maybe that broadens perspective where this, where the technical kind of innovation is right now on the cloud.
Yeah, because sometimes I think about it and I'm like, okay, stay away from streaming if you can afford it, if you can figure it out, because like download and play is kind of boring. But I thought there was also stuff like Video.js, I think it is, or something like that. JW Player, that's right, JW Player, where essentially you just host a file and then everybody knows how to play back that file and the protocol figures it out for you. But you need their software stack to do that with the file. So all of that, like for me, contributed to the different things mean different things in different scopes and different places. But at least now, I have a better understanding of like the distribution and the new challenges, high quality, lossless video streamed. And if you can't do that, then, solve the problem that you have specifically. Call a video expert.
I'm gonna jump in here. I want to do our raffle. And I'll say, we actually ran out of AWS credits, but heroes get dispensation to give away credits anyway. So this time it's a $50 credit. And the way we do things here is we ask a trivia question and then you answer in the chat, and the first one who gets it gets it. And usually I ask sci-fi questions, and I'm not going to do that. And we do have a quick question, but Alex, is there a trivia question perhaps related to video you'd like to ask the group?
I don't have one off the top of my head.
Okay, we have it then. So if you would like one of these $50 credits, type the answer in the chat. And the question is, which sports leagues currently use AWS media services? You need to list two. Nice answer, John. Yes. Geez, Patrick, that was quick. All right. Yep. There's a whole bunch. All right. So, Patrick, I'm gonna just send this to you, and I would say use this quick before someone looks at our video somehow and figures out what the code is. Okay, Patrick, did you get that? All right, excellent. Okay, we can do a few more questions if you like, but I also want to honor our time commitments to people. So I'd say if there are any burning questions, ask Alex directly, or ask in our Slack, and we'll pass them along. We've got meetings coming up that I'm going to post shortly, but I want to say thank you very much. That was really cool. And I want to figure out how to use OBS to get translation for my next presentation.
Thank you, awesome idea. Thank you, Yaro.
Thank you.
All right. Thanks, everyone. Really appreciate it.
Okay.
Thank you.
Bye.
Bye.
Bye.